Alright, so here we have some fun examples of writing names in a cryptic way, each with their own symmetry, and we're trying to decode what name we have here. This is just something I pulled from our class text. It's a CMP2 book. I think it's a great problem. So here we have our vertical line of symmetry, right? That's the first thing I identify, even before I know what name this really is. Right, you can see that we can just draw this line correctly one more time. You can see what we have here is a vertical line of symmetry because we can fold this shape right down the middle, and that's about it. Okay, and that helps us get started because now we can see that here, right, this letter and this letter over here are images of each other. And even if we don't believe that, we can sketch it out real quick and see that it does work. If we trace these out, you see how they're mirrors of each other. The same with these two letters right here. So what letters actually are behaving in this way, and what are they, what name is this? Well, this is a Z, right? You can see the Z written in cursive, and its opposite in cursive written this way is an E. We have a Z and an E, and here we have the letter N, right, written in this way is the reflection of the letter A. So this is in fact the name Zane, right? Not so obvious, of course. Right, they're changing the way they write the letters, so it does have that type of symmetry. And that's what we'll be doing in each of these problems. This one's a little bit more obvious to me, at least, and you might, differ based on what problem we're looking at. Each of them are encoded in a different way. But here I see this nice horizontal, vertical line of symmetry, and you can see this name is Yvette. Right, we have the Y, and then let me fix that Y. We have our Y, and our V, the E, T, T, and E. I like the way they wrote this E right here to create that vertical line of symmetry. Okay, now we go to this one. This one popped out at me too as well. It's the name Quincy. But how would we know that? Well, what's cool about this one is that it doesn't really have it doesn't have reflection symmetry. What it has is rotation symmetry. So let's just take this shape, and you'll see it. We take it and just rotate it around 180 degrees, and there we are back to the original name. So this has 180 degree symmetry with the center of rotation at the middle of the shape. One more to go. Here is a name that's really hard to recognize, I think, at first, but here we have the name Michael, and you can see that the name is there. I think if you look closely at the M-I-C-H-A-E-L, and this has a rotational symmetry. Oops, same as before. 180 degrees if we turn it. Right, we'll get the same name, and it's written in a way to create that effect, which I think is really great. And there you can see it, right? It's the same as it was before, right? 180 degrees, and we can keep going, right? It doesn't matter what way we rotate, as long as we rotate 180 degrees, we get the same exact name. All right, so that's a nice example of names that are encrypted with reflection and rotation symmetry. I hope you enjoyed.